Jai Jirendra, Namaste and welcome to my channel. Today we are going to solve the 74th question of the problem solving series and the 12th question of the topic string. The difficulty level for this question is medium and this question has been asked in Amazon, Microsoft, Apple, Google, Adobe and many other companies. Let's look at the question. Compare version numbers. So we are given two versions, VR1 and VR2, and we need to compare them. These versions are separated by revisions in the form of dots. So if we see that the version VR1 is greater than, its value is greater than the second version, so we will return 1. If it is less than the second version, we will return -1, and if it is equal, then we will be returning 0. Okay, this is given in the question. And let's see the examples. So the version 1 is 1.2 and then 1.10. Okay, here if you look at it as a decimal number 1.2 and 1.10, 1.2 is greater than 1.10 because here with this we mean that if it is nothing is there, then it's like 200, like 200, like this. But it's not here in the same way. Here they are, these versions, revisions, these numbers are separated by dots, so they are individual to it. That means whatever is there before this dot, we need to compare this value. So since this 1 is equal, then we need to compare the next value till the time we don't have dot. Okay, so like for example here there are 3 dots, right? So here there are 4 versions here and there is only 2 versions here. Okay, here there are 2 versions, right? One and then this one, second version. So this 2 and 10, we need to compare it individually. Which is greater? 2 is greater or 10 is greater? Of course 10 is greater, right? So since version 1 is less than version 2, so we will be returning -1. Got it? Now here version 1 and version 2, this is same. After the decimal we see this is 01. 01 is equal to 1. These are the numbers, right? Not the decimal values like this. So 001, the trailing 0 doesn't mean anything. Okay? So this 1 and 1, they are same, right? So we will be returning 0 since version 1 is equal to version 2. Okay? Now the third example. In this third example, there are 2 versions here. There are like multiple dots here, right? Multiple revisions of the version, right? So here it's 1.0 and then 1.0.0 something like this. So this first version is same, the revision is same. Then after this revision 00, these are same. After there is nothing, right? So since there is nothing, we will consider it's 0, right? Nothing means 0. So here since there is no value, that means this version and these versions are equal actually. So we will return 0. Okay. So now how do we solve this? What comes into your mind? Like so these are string values, right? And we need to compare it. We need to convert it into integer. So one thing is that, okay, we need to compare. So you need to write the steps, like think about it. Okay. So first we need to convert it into integer. Okay. Integer conversion is required to know which one is greater. Okay. So that is one thing, int conversion. Okay. Secondly, these dots, before the dots comes, we need to find its value, whatever the value is there before the dot. Okay. And if those values are equal, then we need to move ahead. If those values are not equal, then we can just return there itself which one is greater. If 1 is greater, we return 1, if 2 is greater, we return -1. Okay. So we need to do it like this, that we need to separate the dots, right? We need to have the values together, and this point after this, whatever this number is there, these are individual numbers. So we don't have one thing to compare. We need to compare things individually, right? This one. So if there are more numbers, say 2 or 3 like this, so each will be compared, each version will be compared with its own revision, right? So this is the first revision, this is the second revision, this is the third revision. So we'll have multiple revisions, we'll store multiple revisions and then we'll convert, okay? We will compare, okay? So first we will need to store them in an integer, right? And we can't store them together because 1.2 and 1.10 here, 1.2 is greater, but that doesn't supposed to happen here. Here these are individual numbers. So what do you think? If we store these values separately, this one, then this one, then compare. Okay, one is same. Now let's compare this. Okay, now let's compare this. So for example, if I take an example of 2.04.05.7, okay, and here it's 2.4.005.71. Okay, now which one is bigger, right? So here we will see, okay, so this first number will compare 2 is same, 4 and this 4 both are same. We need to convert it into integer, right? So since both are same, we'll go ahead. 005 and 05, these are also same. Then we'll go and compare, okay, which one is bigger? 7 is greater, or say with 70 also. Then 70 is greater than 70 is greater than 7, right? So this is greater, then we will repeat it, right? So this is the process we need to follow. So to do this, we need to store all these numbers in a vector of integer, or any vector, any array, all the numbers that are separated by dots in both the versions, and then compare them, right? And then say which one is bigger. And also we need to remove this this 005 and 5, they are same, right? So we need to make this happen that 005 is considered as 5 only. That logic we need to add. That is the second thing. And the third thing is, for example here, so when we convert this array here, 1 and 1, it's same, 0 and 0 is same, but after that there is nothing here, but there is something here. So these zeros which don't have any number, if we start comparing, if we see 0 from there is no number, we need to remove these zeros, right? Because we are not comparing these zeros. So if there are suppose 1000 zeros and there's 1000 zeros like this, but those zeros doesn't mean anything to us, so we will just ignore them. So we will need to add this condition as well to optimize our code, right? Okay, so let's code it directly. So what we have discussed, we will take a vector of int v1, v2, okay, and then we will take say this we'll take a string temp, empty string, okay, string temp, to store these continuous values, right? Because it could be like multiple numbers before the decimals. Okay, so string temp is value, and then what we do, let's go through this array. So string for I equal to 0, I less than ver1 dot size I plus plus. Okay, now here if ver1 I is equal to a dot, that would be one thing, if it is equal to dot. Otherwise, if it is not equal to dot, else if it is not equal to dot, so if it is not equal to dot, so like if this is like say 12 and this is 12, so this is not equal to dot 1 2, so these are together, right? So we need to append these values, temp plus equal to veri, okay. So this value would be appended to this temp string, right? Yeah, else this would be there. Otherwise, if we have dot, that means we will push the value of, because we have got the number, we want dot push back, we'll push this temp here, okay. So we'll have the value stored in the vector 1, right? Like this example, if we follow this example, so this we will store 12 in this v1, okay. So the first element would be 12, okay. This is complicated, we'll do it here, okay. When we'll try run it, we'll do it, and then we'll make this temp as empty, okay, so that we can take the new number from the beginning, okay. So this is the condition, else temp is equal to v1. So we have done this, okay. Same thing we will do for version 2 as well, okay. We will get our version 2 this thing, okay. So I'll put it, no problem, but this is same thing, right? Same for v2, okay. We have got the numbers for this same for v2 vector, okay. We got the numbers. Now we have got the numbers separated, the dots are separated, and we can compare them now. Also one more thing, we have stored here v1 dot pushback temp. Okay, what is temp? Temp is a string, but our vector is an int. Okay, so this temp storing this string value of 1. Okay, that will not help us. We need to convert this into integer value, and we can convert it using a library, or you can code it yourself, but it's better to use the library, right? We have the library to convert a string to an integer, right? Stoy. We even solved the question of how to how this stoy works, or ATOA, right? Integer to integer, string to integer conversion. The same library, there is a library for that, so we'll use that stoi temp. That will convert the values. Okay, so this 12 will be a number now, so we can directly compare them. So this is done for V2 also. Now one thing is there, we are talking, we will ignore the zeros, whatever we are getting from the, we'll start from the last element of the V1, V2 vector, and then we will ignore if there is any zero that is there, only zero number stored in the vector. What I am saying is, if V1 is this numbers, okay, we took this example, right? 12, 4, okay, 12, 4, 5, 7. Say after that there are multiple zeros, okay, and V2 is say 12, 4, 5, 71, and then or 70, 0, 0, 0, okay. Here in this case we'll ignore these zeros. Maybe this would have been equal, then we could have compared continuously, right? But this is not part of the comparison if they are zero. No point of comparing it. So better we'll ignore it, so that if there is a very big number having only zeros, we are not comparing it. Okay. So to do that, we will just write a function where I'll just do things for V1. Okay. And later in the code walkthrough, you can see when we submit the code in the LeetCode platform, so you'll see that on the whole code. Okay, so for I equal to v1 dot size I greater than equal to 0, I minus minus. Okay, so if v1 I equal to 0, then we erase that. v1 dot erase v1 dot begin that position, okay, plus I. So whatever the 0 is there, if any 0 is there, we will delete it. We don't need it. Okay. Same thing will be done for v2 as well. Okay. Now the main code. So what we will do, if v1 dot size is m is equal to, so let's have, if v1, let's because we need to traverse one of the array, right, one of the vector, so we'll have that m is equal to v1 dot size. Okay, and if m is less than v2 dot size, if m is less than v2 dot size, then we can say m is equal to v2 dot size. Okay. Now we will traverse this array for I equal to 0, I less than m, I plus plus, and we will see if v1i is greater than v2i, then we return 1. Else if v1i is less than v2i, then we return minus 1. Okay, otherwise this will be continued, right, till the last point. Also, if before this we will see, we will have that v1 and v2 vector. So if v1 is equal to v2, in the beginning only we will return 0. So once we get this array, so if the array is same, for example here in this example 1.0, v1 will be 1 0 and v2 also will be 1 0. So in the beginning only we'll check. If they are equal, then we will return 0. We don't need to go through this. Okay. But if they are not equal, then we will first, this can be done in the beginning, before this also, right, before deleting this numbers. Okay. But if you delete the numbers, after deleting only you will do it, because that time they are not equal, right? You need to remove the extra zeros which we don't need. Okay, so if v1 is equal to v2, return 0. Otherwise, do this condition of checking all the numbers in the array from the left side. We will check the vector of v1, and this is done. Say if after passing we see now whosoever size is greater, if v1 dot size is greater than v2 dot size, if this is done and we have not got the result still, so whosoever size is greater, since we have removed 0 already, so if v1 size is greater than v2 dot size, then we return 1, else we will return -1. Okay, I hope you have understood the question. The link to the question is given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 75th question. Compare version number in the LeetCode platform. You can see this question here. We have discussed this. These are the same examples that we have discussed. And this question has been asked in these companies recently. Nextdoor, Amazon, Microsoft, Zoho, Adobe, Meta, Google as well in the last 6 months. Okay. So let's look at the solution. We have done the same thing. We've taken the vector v1, v2 string temp, and for version 1 we have done this logic. Same logic we have repeated for version 2 here. Okay, this is one thing which we have missed here. So once we have done here, okay, the numbers, after that at the end, when there won't be any dot, okay, like for example 1.2, 1.10, there is no dot here. So the temp will already have, for example this one, temp will have 1, we get it in v2, 1, 0, and then temp will have v2, that's 1, 0, but there is no dot, so we have not added this 10 here. Okay, so this 10 we can see if temp is not equal to, if temp is not having a any value, then we will store that value in the vector, right? This 10 has to be stored. So this is this logic I missed to write during the code explanation. So we need to add this, and the same thing we need to do it for v2 as well. Okay, add the last number after the decimal. Once we have done this, then we can remove the extra zeros which is there here in the numbers. If there is any extra zeros, like here you can see this 1.0.0, so these are zeros, they don't mean anything, so we need to remove these extra zeros wherever it is there. Okay, same thing we need to do for v2 as well. And then if v1 is equal to v2, we return 0, and otherwise we have the size, we take the size, whatever the maximum size is there, and then we can traverse them. Okay, and yeah, so if it is equal, less than -1, otherwise 1. If it is equal, then continue. So if you can remove this logic also, it won't matter. Okay, so yeah, we'll pass this, and if otherwise, so I think if we are traversing here, if m is equal to e1, if m is greater than v2 dot size, we take v2 dot size, because we want to traverse the smaller size, right? Because otherwise we'll have this index out of array issues. After this we are done. If there is any extra number, then we see, compare it, and if v1 is greater, we return 1. If v2 is greater, then we return -1. Okay, so yeah, let's run this. So it has been accepted, and then let's submit this. So it has been accepted. So I think you have understood this question. This is one of a very good example of string question. So see you also in the next video, where I am explaining the 75th question of the problem solving series and the last question of the topic, string. Jai Jinendra.